Welcome to the deep dive. Today, we're tackling a question that's kept, philosophers and physicists up at night for centuries. What is reality? And to explore this, you've given us something deceptively simple, an apple.
It's fascinating how something so commonplace can be a gateway to such profound questions.
Right. Like we see this apple, we smell it, touch it. Seems pretty real, right? But then even early humans were questioning if there was more to reality than what our senses were telling them. Those burial rituals from thousands of years ago, they're like whispers from the past, hinting at a search for something beyond the physical world. What do you make of that?
It's as if they intuited that there's a deeper layer to existence. Take Plato's allegory of the cave, for example. Those prisoners chained in the darkness, mistaking shadows for reality. It's not so different from us taking sensory experience at face value.
So are we all just prisoners to our limited senses? Is there a way to break free and see the true forms, the real reality, as Plato called it?
That's the million-dollar question, isn't it? And science, in a way, is our attempt to break free from those chains, to use observation and reason to see beyond the shadows.
And sometimes that process of seeing beyond involves questioning the very things we thought were fundamental, like color. This apple, for instance, we perceive it as red. But we know that color is not inherent to the apple itself, but rather a product of how our brains interpret light wavelengths.
And it's not just about humans. The mantis shrimp, for example, sees a spectrum of color we can't even begin to fathom with our limited visual hardware. So whose reality is more accurate? Theirs with a kaleidoscope of colors we can't even perceive, or ours? It starts to feel like the very notion of an objective red starts to crumble a bit, doesn't it?
It really makes you wonder what else we might be misinterpreting. What other aspects of our perceived reality are just products of our limited sensory and cognitive frameworks? Like we assume time moves at a constant pace for everyone. But then Einstein comes along and says, hold my beer.
And with that, he completely upended our understanding of reality. Einstein showed us that space and time are not separate static entities, but rather interwoven into this flexible fabric that's warped by gravity and relative motion.
So time isn't this constant tick-tock that's the same for everyone everywhere. It's more like a personal metronome that speeds up or slows down depending on how fast you're moving relative to something else. Did I get that right?
You're exactly on the right track. Imagine this. You're on a spaceship hurtling through space at close to the speed of light. Time on your ship would actually slow down relative to, say, someone back on Earth. When you return, you'd have aged less than they have. You'd literally be a time traveler.
Okay, now that's what I call mind-bending. Our apple might decay at the normal rate, but someone traveling at near light speed would see it age incredibly slowly. But even without a spaceship, we experience this relativistic effect in our daily lives, right? With GPS satellites, for example.
Absolutely. GPS satellites have to account for the fact that time moves slightly faster for them in orbit than it does for us down here on Earth. It's a real-world testament to the mind-blowing fact that time is relative, not absolute.
It's like we're living in a science fiction novel, except it's real. And speaking of mind-blowing, let's dive even deeper, shall we? We've talked about our perception of this apple, how motion warps time. But what about the apple's fundamental building blocks? It turns out that even those aren't as straightforward as they seem.
Indeed. If we were to zoom in on this apple way beyond what even the most powerful microscope can see, we'd enter the strange and fascinating realm of quantum mechanics.
The realm where things get really weird, right? Tell me more.
Imagine shrinking down to the size of an atom, then smaller to the level of protons and neutrons. Even those we now know are made up of even tinier particles called quarks. And here's where our apple starts to get really strange.
Do tell.
Well, these quarks, they don't exist in any fixed location. Instead of like tiny billiard balls, imagine them as more like fuzzy clouds of possibility. It's not until we try to observe them to pin them down that they collapse from a wave function into a definite state.
So you're saying this solid-looking apple is at its core a bunch of blurry possibilities. That's wild. It makes you question what solid even means, honestly. Is it all just an illusion?
It's one way to look at it, and it gets even more mind-boggling when we consider the concept of quantum entanglement. Imagine two of these particles linked in a way that even when separated by vast distances, they still influence each other instantaneously. Measure the state of one, and you instantly know the state of the other, no matter how far apart they are.
Wait, instantly? As in faster than the speed of light? Didn't Einstein have something to say about that?
He did. Einstein called it spooky action at a distance because it seemed to violate his theory of relativity. Even he struggled to reconcile the strangeness of the quantum world with the universe he had so elegantly described.
It's like the universe is playing a game of cosmic hide-and-seek, with different rules at different levels of reality. So where does that leave us? If reality can be relative, probabilistic, and even spooky, how do we even begin to grasp its true nature?
That's where things get really interesting. Because in a way, physics is showing us the limits of our classical intuitions about the world. It's forcing us to expand our minds to consider possibilities that seem outright impossible from our limited human perspective.
And we haven't even touched on some of the wilder theories out there, like the idea that our universe could be a hologram or a simulation. But before we spiral down that rabbit hole, let's bring it back to our trusty apple. We've explored its nature from the perspective of our senses, the relativity of time, and even the quantum fuzziness of its very building blocks. But what about us, the observer? Where do we fit into all of this?
Excellent question. Because it's not just the apple that's complex. We, the observers, are equally fascinating. And that brings us to some of the most profound questions about consciousness, identity, and the nature of the self.
So we've gone from the cosmos to the quantum realm, all using this apple as our guide, but now let's turn the spotlight inward. If reality is so slippery, what about our own sense of self? Who are we in this grand, weird universe?
It's a question philosophers have grappled with for millennia, and the deeper we dive into physics, the more those philosophical questions seem to intertwine with the scientific. We're no longer just pondering the apple's existence, but our own.
Right, like we intuitively feel like us is constant. But our sources mention the ship of Theseus thought experiment. If we gradually replace every plank of wood on a ship, is it still the same ship? And what does that say about us since our bodies constantly replace cells?
It challenges our assumptions about identity, doesn't it? Are we the sum of our physical parts constantly in flux? Or is there something more enduring, something that transcends the material? This is where the mystery of consciousness comes in.
That hard problem of consciousness, as some call it. We still haven't figured out how this mushy gray matter in our skulls gives rise to subjective experience, to the feeling of being me looking at this apple. So if we could build a computer complex enough to simulate the human brain, would it also be conscious? Would it have an inner world like we do?
And if so, would that make its reality as valid as our own? It's a question with huge ethical implications for artificial intelligence. But it also circles back to our own place in the universe. If consciousness isn't limited to biological brains, does that mean it could be a fundamental property of the universe itself?
Well, like some kind of universal consciousness. So maybe the apple is aware on some level too. That's a pretty radical idea. But then we've already gone from questioning color to wondering if we're all just holograms. At this point, nothing seems off the table.
And that's the beauty of this exploration, isn't it? We started with something as simple as an apple, and it's opened up these infinite avenues of inquiry. It highlights how much we still don't know, how much is left to discover about the nature of reality, both out there and within ourselves.
Tumbling for sure, and a bit dizzying. But I think that's what makes this deep dive so fascinating. It's not about finding all the answers, but rather embracing the mystery and asking better questions. So to wrap things up, what would you say is the biggest takeaway from all of this? What should we be pondering next time we encounter a simple apple?
Perhaps this. The apple is not just an object, but a reflection of the vastness and mystery of the universe itself. Every bite is a reminder that reality is far stranger and more wonderful than it appears. It invites us to stay curious, to keep questioning, and to never underestimate the power of a simple object to unlock the secrets of existence.
Beautifully said. And on that note, we'll leave you with this final thought. What if the apple is just the beginning? What other seemingly mundane things in our everyday lives hold the potential to crack open our perceptions and reveal a deeper, more profound reality? Keep looking, keep questioning, and who knows what wonders you might uncover. This has been The Deep Dive. Thanks for joining us.